Okay, to finish off this section, let's look at a definite integral. And at the same time, even what we're needing to integrate is going to be something new as well. So here, this is the integral from 1 to e for natural log x dx. Now you may remember back several examples ago, we thought about, hey, what is the antiderivative of natural log x? And we realized we never learned that. It's not something that we teach in Calc 1 because to get the antiderivative of natural log x, you actually need integration by parts. Okay, interesting. So let's think here. Looking at that integral, well, first thing we need to do is use integration by parts, right? Then we'll worry about the limits. So let me write that formula again. Okay. Now, when you look at this, natural log x dx, you're like, but we're supposed to be multiplying two things. I don't see what's being multiplied there. There actually is multiplication. It's just so simple that it can slip by. It's sometimes we say it's so simple it's confusing. What's u and what's dv? Well, if there's only the one term, then that's u, and dv is simply the dx. And that's how it's got to work. That's the only way that this could work as an integration by parts. U is natural log x, and dv is simply dx. Okay, well, let's see how that plays out. I've got it over here to the side. U is natural log x, dv equals dx, and so du is 1 over x dx. And v, antiderivative, this is almost so simple it can be confusing. Well, it's just x, right? Because almost think of this as like, the differentials, the differential. So, or it's like a 1, right? Antiderivative of 1 times dx is x. Okay, now using our formula, let's put it all into place. And we'll remember it is a definite integral. Okay, so we've got uv, let's just write it as x natural log x minus v du. Like that. And we'll repeat those limits 1 to e there on that integral. Okay, hey, this is great. X times 1 over x. Well, those cancel out. And we've got x natural log x minus integral from 1 to e dx. Well, what's the antiderivative of dx? Well, we saw that back here. It's simply x. And so we come to x natural log x minus x from 1 to e. And now we can plug in. Remember, plug in the e, then subtract and plug in the 1. I'll just kind of slide this up. So plugging the e in, e natural log of e minus 1 natural log 1 minus 1. And at this point, you'll need to remember your rules for natural log of e, natural log of 1. Natural log of e equals 1. And the natural log of 1, do you guys remember what the natural log of 1 equals? And if you don't, grab a calculator. If you do, even better, that is 0. So our answer here, we've got e times 1 minus e, 1 times 0 minus 1, e minus 1 minus 0. This whole thing is actually just equal to positive 1 as your answer there, which is kind of cool. And there you go. So doing a definite integral, well, really, there's not much to it. Just be sure to plug your numbers into the end. There is one concept we should point out, and most of the time, this is, you're perfectly fine, but I do want you guys to be aware. Usually people write the first line of the biparts this way. Just your uv minus integral v du, and when they do that new integral, you repeat the limits there. So you think, well, wait a second though, these limits don't just apply to this. Eventually when we got it, we applied those limits of integration to the entire thing. But this seems to indicate otherwise. Technically, at this line, and most people don't write it because we get it, but technically you should write that line here because this part is already integrated and you need to plug those in. So you write that line, okay. And then once you do the whole thing, and then we probably should technically write it there. And then once you get all of it, then we can just write it the once and we know it goes to everything. Although most people don't write it here. And I will not be. Okay, guys, that is 7.1. That was heavy. You got a lot of homework in front of you. We do not start off light in this class. We start off strong. So go for that homework. Bring your questions to office hours next time, and go for it. You got this.